8:42 p.m. Etna's southeastern crater begins to glow. Tourists point their cameras skyward, expecting another spectacular lava fountain. Instead, they witness something unprecedented, an eruption that executes itself. For the first time in recorded volcanic history, rising magma encountered what scientists now call a stress guillotine, a zone of crustal pressure so intense it can decapitate eruptions mid-ascent. The magma that should have illuminated Sicily's night sky instead detonated underground, down, sending shockwaves through the Mediterranean. But this was not a random volcanic hiccup. Analysis of Etna's seismic patterns reveals a disturbing truth. The mountain has been systematically building execution chambers beneath its surface. They are stress concentration zones, designed to trap and eliminate ascending magma. The question is not why this happened. It is how many more underground execution sites are waiting to be triggered. When did Mount Etna learn to execute its own eruptions? What created these geological guillotines beneath Sicily? And if the volcano cannot erupt naturally anymore, what happens to all that trapped energy? Mount Etna isn't just Europe's most active volcano, it is 500,000 years old. Rising from the collision zone where the African plate grinds beneath Europe, this 11,000-foot monster has been terminating civilizations since before recorded history. The Romans called it Etna Mons, the burning mountain, but they never witnessed what we are seeing now. For 2,700 years, Etna followed predictable patterns. Magma rises, pressure builds, and eruptions occur. A simple, brutal cycle that created the fertile soils feeding 1 million Sicilians. But in December 2018, that pattern broke. Dr. Marco Ferretto Carlino at Italy's National Institute of Geophysics discovered something that should be impossible. For decades, we tracked the B value, the ratio of small to large earthquakes beneath Etna, he explains. This ratio acts like a volcanic heartbeat, changing as magma rises through 19 miles of crust toward the surface. But that heartbeat flatlined. Seismic data showed magma ascending normally through the deep crust, following pathways carved over millennia. Temperature sensors confirmed rising heat. GPS stations detected ground swelling. Every instrument screamed eruption imminent. Then, at 2.3 kilometers depth, the magma stopped. Dr. Elena Giampiccolo, who led the investigation, warns that we are not talking about cooling or solidification. The magma encountered a stress concentration zone so powerful it terminated the entire eruption sequence. The energy that should have created lava fountains instead triggered a magnitude 4.9 earthquake, the strongest in decades. Real-time seismic monitoring revealed the terrifying truth. Etna had constructed its own execution chamber. This was a zone where crustal stress reaches levels that can strangle ascending magma and redirect that energy into seismic weapons. But the 2018 event was not isolated. Analysis of 20 years of seismic data reveals a pattern of systematic execution chamber construction throughout Etna's underground architecture. The implications extend far beyond Sicily. Etna sits on the Siculo-Calabrian Rift Zone, a fracture network 370 kilometers long that connects volcanic systems across the Mediterranean. When Etna's eruptions are executed underground, the energy does not disappear. It transfers as stress waves through this network, potentially triggering earthquakes and volcanic events hundreds of kilometers away. Each aborted eruption creates a stress pulse that propagates through the Mediterranean seafloor. Emsan explains Dr. Luciano Scarfi of Italy's earthquake monitoring network. We are essentially watching Etna build seismic bombs that can detonate across 3 countries. This is not the first time Mount Etna has weaponized its own volcanic system. History reveals a disturbing pattern. Whenever Etna begins executing its own eruptions, catastrophe follows. archaeological evidence from Santa Venera al Pozzo shows massive structural damage from an earthquake that struck 1 year before a major Etna eruption in 251 CE. Dr. Alessandro La Spina, who excavated the site, argues the timing is not coincidence. Historical accounts describe the earthquake as following the mountain's refusal to breathe, likely the first recorded eruption, execution. The 251 CE earthquake devastated Roman settlements across eastern Sicily. Contemporary historians focused on the following year's eruption, and so missed the connection between Etna's underground execution system and regional seismic catastrophe. The most destructive eruption in Etna's recorded history began with something unprecedented in 1669. 3 weeks of increasingly powerful earthquakes destroyed multiple towns before any magma reached the surface. Seismic activity peaked on March 10th when earthquakes leveled Nicolosi, then mysteriously ceased. Dr. Stefano Branca, a volcanologist, notes that the 1669 pattern matches exactly what we are seeing now. He says massive stress buildup, systematic underground execution of rising magma, then sudden catastrophic release through alternative pathways. When Etna finally erupted on March 11th, it was not from the summit, it was through a 9-kilometer fissure that opened like a surgical incision along the southeastern flank. The eruption lasted 4 months, buried 14 villages, and nearly destroyed Catania. But the most terrifying historical precedent occurred in 1169, when Etna's execution system triggered a magnitude 7+ earthquake that generated tsunamis across the eastern Mediterranean. The event killed over 15,000 people and demonstrated how Etna's underground stress bombs can propagate far beyond Sicily. Contemporary accounts describe unusual volcanic activity preceding the earthquake by weeks, explains earthquake historian Dr. Romano Camasi. He says the mountain was groaning but not breathing. Classic signs of systematic eruption execution. The 1169 event proves that when Etna cannot release energy through normal eruptions, it finds more destructive alternatives. The stress bombs built through eruption execution do not just threaten Sicily, they can trigger seismic cascades throughout the Mediterranean basin. What makes the current situation unprecedented is the frequency. Historical execution events occurred once per century. Since 2018, Etna has been systematically executing eruption sequences multiple times per year. If the current pattern continues, we are not just facing another eruption. We are staring at the Mediterranean's most catastrophic geological event since the Bronze Age collapse. Here is how Etna's underground execution system could trigger a cascade that reshapes 3 continents. Monitoring data shows Etna's execution chambers are becoming more efficient. The volcano is systematically aborting eruptions at shallower depths, 1.8 kilometers, then 1.2 kilometers. Each execution creates larger stress bombs that propagate deeper into the Mediterranean fault network. Dr. Ferretto Carlino warns the stress bombs are getting more powerful, and they are being positioned closer to critical fault intersections. Current projections suggest Etna will attempt another major eruption within 3 to 4 months. If the execution chambers strangle this event at depths less than 1 kilometer, the resulting stress bomb could exceed magnitude 6.5, powerful enough to trigger the Siculo-Calabrian rift system. A magnitude 6.5 or greater earthquake centered beneath Mount Etna would not just devastate eastern Sicily, it would propagate through the island's limestone bedrock like a seismic bullet. Catania, home to 300,000 people, sits directly above this transmission pathway. Within minutes, buildings constructed on volcanic ash deposits would begin liquefying. The port of Catania, Sicily's primary commercial hub, would collapse into the Mediterranean as seaborne stress waves trigger underwater landslides along the continental shelf. But the shockwave would not stop at Sicily's shores. Stress pulses travelling at 8 kilometers per second would reach the Calabrian arc within 90 minutes, potentially triggering dormant faults that have not moved since the 1783 sequence that killed 50,000 people. The Sicily-Calabrian rift zone functions like a stress transmission cable 370 kilometers long, connecting volcanic systems across the central Mediterranean. When Etna's stress bombs detonate, they do not dissipate, they propagate. Vesuvius, dormant since 1944, sits at the northern terminus of this network. Stress pulses from Etna's execution chambers could reactivate Vesuvius's magma system, potentially triggering the eruption that volcanologists have feared for decades. 3 million people live within Vesuvius's destruction radius. To the south, the stress cascade could destabilize the Sicily seamount, an underwater volcano 175 kilometers off Italy's coast. Sicily contains enough magma to generate tsunamis capable of striking coastal cities from Naples to Tunis within hours. But the most terrifying scenario involves Etna's flank collapse system. Each underground execution weakens the southeastern slope, which is already sliding into the Ionian Sea at centimeters per year. If stress bomb detonations accelerate this sliding, we could witness the catastrophic flank collapse. That geological evidence suggests occurs every 8,000 years. A flank collapse would displace billions of tons of volcanic material into the Mediterranean, generating tsunamis up to 40 meters high. Waves would strike Malta within 15 minutes, reach the Greek islands within an hour, and slam into North African coastlines, carrying the power to penetrate dozens of kilometers inland. Tsunamis. The Mediterranean carries 20% of global shipping traffic. A single tsunami event would shut down ports from Barcelona to Alexandria, severing supply chains feeding 500 million people. Coastal cities housing the region's major airports, Rome, Athens, Barcelona, and Tel Aviv, would be crippled or destroyed. Insurance estimates suggest total economic losses could exceed $2 trillion, making this the costliest natural disaster in human history. The refugee crisis would dwarf anything Europe has experienced, as coastal populations flee inland, abandoning cities that took millennia to build. The threat is not theoretical anymore. Real-time monitoring reveals that Mount Etna's execution chambers are expanding, strengthening, and coordinating in ways that suggest we are approaching a critical threshold. Italy's National Institute of Geophysics operates 125 seismic stations and across Sicily, creating the world's most sophisticated volcanic monitoring network. Since 2018, this network has detected a disturbing acceleration in Etna's execution patterns. Dr. Marco Ferretto Carlino reports that the B value changes are happening faster and more dramatically. What used to take months now occurs in weeks. The mountain is systematically optimizing its execution process. GPS stations show the southeastern flank sliding at accelerating rates, 4.2 centimeters in 2019 and 6.1 centimeters in 2023. Each execution event correlates with increased sliding velocity, suggesting the underground stress bombs are destabilizing the entire volcanic edifice. Satellite thermal imaging reveals temperature anomalies in areas where no surface volcanic activity occurs, evidence of heat generated by underground stress concentration. These thermal signatures appear weeks before execution events, providing a new early warning system. But the warnings are accelerating. In 2018, thermal anomalies appeared 6 weeks before execution. By 2024, that window has shortened to 10 days. Dr. Elena Giampiccolo explains that the mountain is giving us less and less warning, and it is becoming more efficient at hiding its execution preparations. Ground deformation data shows unprecedented inflation patterns, the mountain swelling asymmetrically as execution chambers redistribute stress throughout the volcanic architecture. This asymmetric swelling matches historical patterns that preceded major flank collapse events. Stress modelling suggests Etna's execution system is approaching a critical threshold where it can no longer contain the energy it is concentrating. Computer simulations indicate this threshold could be reached within 18 to 24 months if current acceleration continues. Dr. Luciano Scarfi warns that we are watching a volcano arm itself. Each execution makes the next one more powerful. Each stress bomb makes the Mediterranean fault network more unstable. At some point, the system will not be able to contain what it is building. The most alarming development is the synchronization. Execution events that once occurred randomly now follow predictable patterns linked to Mediterranean tidal cycles and regional seismic activity. This suggests Etna's system is responding to and potentially influencing geological processes across the entire basin. The better our monitoring becomes, the more terrifying the data gets. Advanced seismic imaging reveals execution chambers extending far deeper than previously thought, some reaching 15 kilometers beneath the surface. At these depths, stress bombs could tap into regional fault systems that extend across multiple countries. Yet for all our technological sophistication, we can detect execution events only hours before they occur. The mountain has become a master of geological deception, hiding its most dangerous preparations until the moment of detonation. Dr. Ferretto Carlino admits that we can see what Etna is doing, but we cannot stop it. Mount Etna's execution system isn't unique. It's a blueprint that other volcanic systems worldwide are beginning to copy, threatening to transform how we understand and fear volcanic eruptions globally. Satellite monitoring has detected similar stress concentration patterns developing beneath Stromboli, Italy's other active volcano, just 50 kilometers from Etna. Dr. Alessandro Laspina reports that the stress bomb signatures are identical, and that it is as if Stromboli is learning from Etna's execution techniques. More disturbing, volcanic systems outside the Mediterranean are showing early signs of execution chamber development. Japan's Mount Fuji exhibits asymmetric stress patterns that match Etna's pre-execution signatures. Indonesia's Merapi volcano has begun aborting minor eruptions in ways that mirror Etna's 2018 event. What makes this global copying so dangerous is the interconnected nature of modern volcanic monitoring. Stress waves generated by execution events do not respect national borders. When Etna's underground bombs detonate, the energy propagates through oceanic fault systems that connect to volcanic regions thousands of kilometers away. Recent analysis shows correlation between Etna's execution events and increased seismic activity along the mid-Atlantic ridge. Dr. Elena Giampiccolo explains that we are seeing evidence of stress transmission across entire ocean basins, and that Etna's execution chambers may be triggering geological responses as far away as Iceland. Mediterranean shipping represents the blueprint for global trade. If Etna's execution system triggers the predicted cascade, it would not just destroy regional commerce. It would demonstrate how volcanic execution chambers can weaponize geological systems to attack economic infrastructure. Insurance companies are already recalculating volcanic risk models based on Etna's execution patterns. Lloyd's of London issued internal warnings that traditional eruption insurance does not cover systematic volcanic self-termination events and the resulting seismic cascades. If volcanic execution chambers spread to major volcanic systems worldwide, we could face a new era of geological warfare where volcanoes systematically convert their eruption energy into seismic weapons. The Yellowstone system, Indonesia's Toba caldera, and Italy's Campi Flegrei all possess the geological architecture necessary for execution chamber development. The ultimate nightmare is synchronized execution events across multiple volcanic systems, creating a global cascade of stress bombs that could destabilize tectonic plate boundaries simultaneously. Computer models suggest such an event could trigger a geological reset comparable to the mass extinction events that ended previous geological eras. We are not just watching Mount Etna learn to execute its own eruptions. We are watching the birth of a new form of planetary self-destruction. Tonight, as you sleep, Mount Etna is building another execution chamber. Stress concentration zones are crystallizing 6 miles beneath Sicily, preparing to strangle the next eruption attempt and convert that energy into a seismic bomb powerful enough to reshape the Mediterranean. Every earthquake beneath your feet, every tremor that rattles your windows, could be the stress wave from Etna's latest execution reaching your coastline. The mountain has learned to weaponize its own volcanic system, and now it is teaching other volcanoes worldwide to do the same. But here is what keeps volcanologists awake. We can monitor Etna's execution chambers, but we cannot stop them. Each stress bomb makes the next one more powerful. Each execution brings the Mediterranean closer to a cascade that could rewrite the geological rules governing our planet. The question is not whether Etna's execution system will trigger a catastrophic cascade. It is whether we will recognize the warning signs before it is too late. What do you think happens when a volcano masters the art of geological execution? Have you noticed increased seismic activity in your region that might be connected to Etna's stress bombs? Drop your theories in the comments below and make sure you are subscribed, because this story is far from over. This is Earth Attacks, equipping you with critical information about the planet. Sometimes the greatest threats come from the mountains that turn against themselves. Hit that notification bell. You cannot afford to miss what Etna does next.